This video is on coordinate geometry, plane shapes. These are going to be examples of how to classify the triangles in the most precise way possible using slopes and distances. We will also be finding the perimeter of each. Now it is important that we know that we should show all of our work. So I'm going to make a note up here that all work must be shown. Must be shown. Because we have to actually prove that this is in fact happening and not just our assumption that the lines are parallel or the lines are congruent. We have to make sure that our work supports this information. Okay, so our first example, again, we're going to classify the figure in the most precise way possible using slopes and distances. We'll find the perimeter of each after we've done this. Our first example is a graph, so we can find slopes and distances using the coordinates. We actually have a table down here to help us stay organized. On the left-hand side, we're going to name our sides using our segments. Then we'll find our slopes. Then we'll find our length of sides or our distance using Pythagorean theorem. So on the first piece, I'm going to put down our side length. So I have triangle ABC. So I know this is a triangle. I want to classify this triangle as scalene, isosceles, or equilateral, and also potentially acute, obtuse, and right. So our first side length is AB, or our first side is AB. So we would call this segment AB. So two capital letters, AB, and then we'd have the segment on top of it. So this is called segment AB. The next one we will do is segment BC. So two capital letters, BC, with a segment on top of it. The last one I would go from CA. So I'm just going to go in a counterclockwise method, or sorry, a clockwise. Oh, that is counterclockwise, I apologize. Counterclockwise rotation. I started with A, went to B, then went to C. So I'll go from C, then to A. So two capital letters, and then a segment on top of it. So slope. Slope is our change in y divided by our change in x. So I'm going to write that in here, change in y divided by change in x, so delta y over delta x. All right, so from A to B, I can see our delta y from A to B. I'm going to go up 1, so that's a change in y of a positive 1. Then, so I've gone up, I'm going to go to the right, so that's a change in positive of 1, 2, 3, 4, 5, 6, 7. So it's going to be a positive 7 for our change in x. So I would then simplify, positive 1 divided by positive 7 is 1 over 7. So that is the slope of segment AB. I'll do the same for segment BC, so change in y over change in x from B to C. From B to C, my change in y is going to go up, so it's going to be positive 1. It's going to be a 1, 2, 3, 4. So a positive 4 over my change in x. So I went up 4 to get this little spot right here. Then I'm going to go to C by going left, which is a negative 1, 2. So that would be a change in x of negative 2. I would simplify. Positive 4 divided by negative 2 is negative 2. My slope is negative 2 for that line. Then our last slope would be from C to A. Change in y over change in x. And you can go from A to C, but I'm going from C to A, so that is why my slope might have a different sign on the change in y and on change in x than yours, but the slope will remain the same because a positive divided by negative and a negative divided by a positive is the same. From C to A. So I'm going to go from C to A is, I have to go down, so that's going to be a change in y of 1, 2, 3, 4, 5. It's going to be a negative 5. divided by, now I have to go from this point that I created to the left. So that's going to be a negative change in x of 1, 2, 3, 4, 5. So also negative 5. So negative 5 divided by negative 5 is equal to a positive 1. I now have all my slopes. And now I can think about, with the slopes, what information do I have here? None of these slopes are the same, so they're not parallel. And none of these slopes are opposite reciprocals. So we have no perpendicular either. So we have no parallel. And we have no perpendicular. So we do not have a right angle. So it's not going to be a right triangle. That helps us with knowing that our classification is not a right triangle. And we can see that these angles do not look like they're right angles, but we have to prove it showing the perpendicular part. So all of these angles are going to be smaller than right angles because they are not going to be obtuse. So our classification will end up being an acute triangle. Now we're going to find the length of the sides, or the distance. So I'm going to use Pythagorean theorem. From A to B, my A value is going to be my horizontal distance. So I'm going to count 1, 2, 3, 4, 5, 6, 7. I'll have 7 squared plus, then I counted 1 squared equals c squared. Draw my arrow. 7 squared is 49. 1 squared is 1, so 49 plus 1 is 50. We have 50 is equal to c squared. Therefore, our distance is the square root of 50, because I have to take the square root of both sides, units. So the length of AB is square root of 50 units. I went 1, 2, 3, 4, 5, 6, 7, and then I went 1 to get to B. So 7 and then 1. Next, I'm going to do B to C. I'm going to count 1, 2, 3, 4, and then 1, 2. So I'm going to have 4 squared plus 2 squared equals c squared. Now, since I'm just counting, I did not use any negatives. I'm just counting how many spaces it took. When you're doing distance, you never have negatives in here because it's just counting, and you're always counting forward. 4 squared is 16, and 2 squared is 4. So 16 plus 4 is 20. We have 20 equals c squared, which means that our distance is the square root of 20 units. Our last one is from C to A. Again, I'm going to count from C to A. It's going to be 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5. So I have 5 squared plus 5 squared is equal to c squared. 5 squared is 25 plus 25 is 50. So we have 50 equals c squared. That means our length of CA is the square root of 50 units. Now that we have all of our distances, we can compare them. We actually have 2 sets of sides that have the same distance. That means that they are congruent. We have 2, I'm going to write down here, 2 sides are the same. So that helps us with our classification. So going back to our classification, our information, we have scalene, which has no sides the same. Isosceles has 2, and equilateral has all 3. Well, we only have 2, so that means that our classification so far is isosceles. And we can also determine the angle. Since we do not have a right angle, now we can look to see that none of these angles are bigger than 90 degrees as well. So this would be an acute. So this is an isosceles, acute, or an acute isosceles triangle. It is a triangle. We have to make sure that we do put triangle on there because it is only 3 sides. Okay. The last part of that would be to find the perimeter. Perimeter is adding up all the sides, which is why we have this information here. Perimeter is going to be the square root of 50 plus, then the next side is the square root of 20. Actually, I'm just going to do square root of 50 and a square root of 50 since they're the same, plus then the square root of 20. It really doesn't matter which ones you add first because addition is commutative. I just went ahead and put square root of 50, square root of 50, square root of 20. Now I'm going to use a calculator and add those and get to the nearest tenth. So this is approximately 18.6 units. Always put your units when you're dealing with distance, and perimeter is dealing with distance. Our perimeter is roughly 18.6 units. I did not try to simplify the square roots. As long as they're not simplified, I can see that they are the same or not the same because I didn't try to do anything with the numbers. And I did not want to use decimals until the very end of the problem because square root of 50 is an exact value. The decimal would be a rounded value, which would end up making my perimeter slightly off if I rounded ahead of time and then added and then rounded again. This next problem, same thing, it's same triangle, but it's without a graph. So we're still going to be finding our slopes and our distances, but we're going to be doing it without a graph. We're going to have to see how to do the change in y, change in x, our length of a, our length of b, to be able to find our slopes and distances. Again, I'm going to name our side lengths. So we have triangle ABC. So I have A to B is one side. I'm going to label that as segment AB. The next one would go from B to C, and you can see I'm going from A to B, and then I went from B to C. And then I'm going to go from C to A, so I'm going back. I just kept going in a pattern. Next up, we want to find our slopes and our distances. Well, in order to find our slopes, we're going to have our change in y and our change in x. So I'm going to make some notes up here. I'm going to do AB. I need to find my change in y and my change in x. So I'm going to do AB, BC, and CA. That way I can do the math up here so I can do just my fractions in my chart down here. All right, first up, I need my change in y. From A to B goes from -1 to 6. That is a positive 7. Then I want to find my change in x. My change in x is from 4 to 5, which is a positive 1. I'm going to find all of these, and then I'll come down here to do the actual slopes and distances. Next, I'm going to do B to C, same thing. Change in y from B to C, so I'm going from 6 to 3, which is a minusing of 3. Then I'll do change of x, which goes from 5 to 1, which is a minusing of 4. Last is C to A, change in y. I'm going to go from C to A, so I'm going to go from 3 to -1, which is going to be a minusing of 4. Change in x will be from 1 to 4, which is a minusing, or an addition of 3. Now that I have these values, I can do my change in y over change in x. AB, change in y was a positive 7. Divided by a positive 1, which is equal to a 7. Our slope is 7. From B to C, change in y is -3, divided by change in x is -4. our slope is positive 3 over 4. From C to A, our change in y is negative 4 over change in x is positive 3. This slope is negative 4 over 3. Looking at these slopes, I do not have any slopes that are the same, so they are not parallel, but I do have a 3 over 4 and a 4 over 3. Those are reciprocals, and then positive and a negative. So these are actually opposite reciprocals. The slope of 3 over 4 and the slope of negative 4 over 3 tells us that we have perpendiculars. They will be perpendicular. So we will have a right triangle in here. That tells us, this slopes tells us it's a right triangle. So we can put a right in our classification because it's going to be part of our classification. Next, we're going to do our distance. And again, distance was a squared plus b squared equals c squared. And in the graph, it's a little bit simpler to see it because we can just count. But when we don't have a graph, we're still going to do a squared plus b squared equals c squared. Which is still just like c is equal to the square root of a squared plus b squared. But how do we do that without a graph to count? Well, a is just your change in x. So delta x squared plus the b would be your up and down. That's going to be your change in y squared is equal to c squared. That's all a and b really are. So when we do this, you can also do change in y and then change in x because again, it's commutative, it's addition. It doesn't matter which one you do first. With this, I can see from a to b, my change in y is 7. And again, we're not going to use any negatives, but it would count 7 spaces. So that would be 7 squared plus our change in x was positive 1. Again, no need to think about the signs. It's just a 1 squared equals c squared. So we'll end up solving for c. So we're going to take the square root. We'll have the square root of 7 squared is 49, 1 squared is 1, 49 plus 1 is 50. So we have the square root of 50 units again. Next, we have from b to c, our change in, I'm just going to do change in y first, is a negative 3. However, you got to remember that it is just 3 spaces. It just means that we went down 3 spaces, but it's still just 3 spaces. So we would utilize still 3 squared. But if you want to see this with actual numbers, you can do it with the parentheses of negative 3 in parentheses and then square it, which is the format of actually doing the change in y and the change in x. Plus, again, we can do the negative 4 to show that it is just moving left 4, and then we square it. We're going to end up solving for c, so we will have the square root. Negative 3 squared is a positive 9, and negative 4 squared is a positive 16. So 9 and 16 is a 25, which is actually, square root of 25 is in fact 5 units. If it is a perfect square, it would be simpler to go ahead and just say what the length is. Square root of 50 is not a perfect square, so that would have been a decimal. We would have left it. We leave that as the square root of 50. But square root of 25 is 5, so it's a little bit simpler to just say what that value is. All right, last one is from C to A. My change in y, again, you can do change of x first or change in y first. It doesn't really matter. Since it is negative, I will put it in parentheses and put negative 4 squared. Or you can just take the fact that this is just going down 4 spaces and just say 4 squared. It's the same thing because when you square a negative, it becomes a positive. Plus, the change in x is 3, so that's going to be a positive 3 squared is equal to c squared. And we're going to solve for c, so we will take the square root. Negative 4 squared is positive 16. plus 3 squared is 9. 16 plus 9 is 25. And again, the square root of 25 is, in fact, 5 units. All right, now that we have all of the side lengths, we can see that 2 of these side lengths are the same. Square root of 50, 5, and 5. So we have 2 sides are the same. That means that this triangle is isosceles. So it is a right isosceles triangle. Last part of this is to find the perimeter, which is again adding up all the side lengths. We have 5 and 5 and the square root of 50. I'll actually do 5 plus 5 plus the square root of 50. And in a calculator, again, I want to keep this straight as it is without simplifying the square root of 50 for now, and then add them. This will give us a decimal of roughly 17.1 units.